Assalamualaikum and good day everyone. My name is Sayyidatul Aisyah binti Sulaiman and I am from Group 5. The team members are Nadia Sabrina binti Muhammad Azmi, me myself, Ahmad Farhan bin Saidin, and the last one is Nik Nur Alisa binti Muhammad Azmi. So today's presentation is about Group Assignment 2 with the title Total Productive Maintenance TPM and Overall Equipment Efficiency OEE. Before we move further, I would like to highlight the background of TPM. TPM or Total Productive Maintenance is a holistic approach that focuses on optimizing the efficiency and performance of business facilities and processes to achieve the highest possible returns and to maximize business outcomes. Its origin basically is developed in Japan by Nippon Denso, a Toyota Group company in the 1970s. The philosophy is zero accidents, zero defects, and zero breakdowns. It focuses on proactive and preventive maintenance to improve equipment efficiency. So the integration, part of lean manufacturing strategies to eliminate waste and inefficiencies. So there are three objectives of TPM. The first one is to achieve zero defects, zero breakdown, and zero accidents in all functional areas of the organization. The second one is to involve people in all levels of organization. And the third one is to form different teams to reduce defects and self-maintenance. The benefits of TPM, there are 5 benefits. The first one, to increase in productivity and OEE and efficiency. Reduction in customer complaints. The third one is reduction in the manufacturing cost by 30%. The fourth one is satisfying the customer needs by 100%, delivering the right quantity at the right time in the required quality. And the final one is to reduce accidents. So next, let me introduce you to the 8 pillars of TPM, a framework that forms the foundation of total productive maintenance. The first pillar is autonomous maintenance. This focuses on empowering operators to take responsibility for the routine maintenance of their equipment, such as cleaning, lubrication, and inspections. It ensures equipment is always in good working condition, reducing breakdowns. The next is planned maintenance. This is about scheduling maintenance activities ahead of time based on predicted needs, like the lifespan of machine parts to minimize unexpected breakdowns and downtime. The third pillar is focused improvement, which involves identifying and eliminating losses through small incremental changes. This encourages continuous improvement and collaboration among teams. Moving to the fourth pillar, quality maintenance. This focuses on preventing defects in the production process by ensuring machines produce high-quality products consistently. It also involves root cause analysis for quality issues. The fifth pillar emphasizes education and training. It ensures that all employees are equipped with the skills and knowledge necessary to contribute to the TPM process effectively. This applies to both operators and maintenance personnel. So next one is SHE, Safety, Health and Environment. It aims to create a safe working environment, reduce workplace hazards, and ensure the health and well-being of all employees. Seventh, we have Office TPM. It extends the TPM principles to administrative processes such as order processing and inventory management to ensure the smooth flow of information and support for production activities. Finally, Development Management, which focuses on early management of new equipment and products to ensure reliability and maintainability. It aims to integrate TPM principles from the design stage. Okay, now let's take a closer look at Nissan, a global leader in the automotive industry. This slide provides an overview of Nissan's history, achievements, and global presence, highlighting how it has consistently set benchmarks in the market. Nissan was founded in 1933 in Yokohama, Kanagawa, Japan, and operates in the automotive manufacturing industry. Over the decades, Nissan has grown to become one of the most recognized names in the global automobile sector. The company integrates lean manufacturing and total productive maintenance or TPM into its operations. This approach enhances efficiency, reduces waste, and ensures high-quality production. By adopting such practices, Nissan remains a pioneer in innovation and operational excellence. A key highlight of Nissan's strategy is its commitment to sustainability. The company has set an ambitious goal to achieve carbon neutrality by 2050, focusing on cutting-edge technological innovation and delivering value to customers worldwide. About the global presence, Nissan has an extensive global footprint, operating in over 160 countries. Its manufacturing facilities are located in strategic markets including Japan, the United States, Mexico, China, and the United Kingdom. This presence ensures that Nissan stays competitive in meeting diverse customer demands. The key achievements. Amongst its many achievements, Nissan is a pioneer in electric vehicles. The introduction of the Nissan Leaf in 2010 marked a major milestone, positioning the company as a leader in sustainable mobility. Nissan is also known for its engineering advancements, such as innovative safety technologies and fuel-efficient engines. Today, it ranks among the top global automobile manufacturers in terms of sales. So let's continue with the Nissan's application of total productive maintenance (TPM) pillars. This strategy is aimed at improving equipment reliability, reducing waste, and maximizing productivity across their operations. Let's explore how Nissan has integrated these 6 pillars into their manufacturing processes. So the first one is autonomous maintenance. Nissan empowers its operators to manage routine maintenance activities. The approach here is to give operators ownership of basic maintenance tasks such as cleaning, inspections, and minor repairs. The key activities include regular equipment inspections and participating in training to spot anomalies early. The result is the early detection of issues, reduce downtime, and improve equipment reliability through operator engagement. The second one is planned maintenance. The second pillar focuses on preventing unplanned equipment failures. Nissan maintains a proactive approach with a regular maintenance schedule. Key activities involve routine inspections and using predictive tools like sensory to identify potential issues early. This ensures improved equipment reliability and minimize interruptions to production. Focus improvement is about teamwork and addressing persistent losses. The approach involves identifying root causes of inefficiencies and tackling them collaboratively. The key activities include root cause analysis (RCA) and implementing cross-departmental initiatives. This pillar leads to reduced waste and increased output efficiency. The next one is quality maintenance. This is maintaining high standards in production is a priority for Nissan. The approach is to embed quality at every stage of the process to prevent defects. The key activities include implementing error-proofing techniques like Pokayoke and conducting rigorous quality inspections. The outcome is enhanced customer satisfaction and a notable reduction in faults. The next one, the fifth pillar, training and development, focuses on improving the technical proficiency of staff. The approach ensures both operators and maintenance personnel are continually trained. Key activities include workshops for skill development and specialized training programs for engineers. The result is a skilled and competent team capable of maintaining strict operational guidelines. The final pillar is safety, health, and environment (SHE). The final pillar emphasizes sustainability and workplace safety. The approach is to develop a safe and environmentally conscious workspace. Key activities include applying safety procedures, using energy-saving techniques, and aligning with environmental sustainability goals. The result is enhanced safety for employees and compliance with environmental standards. So in conclusion, Nissan's use of TPM pillars showcases their dedication to achieving operational excellence. By integrating maintenance, quality, training, and sustainability into their core strategy, Nissan has created a robust framework that supports productivity, safety, and environmental responsibility. That's all about the TPM pillars. Thank you. I'll pass to my friend.
Okay, so good day, I'm Nadia. So we will discuss overall equipment effectiveness or OEE. That is a vital metric for measuring the efficiency and productivity of equipment or process in manufacturing and other industry. So OEE, as defined here, is a critical performance metric. It reflects the proportion of manufacturing time that is genuinely productive expressed as percentage. So in a simple terms, it tells us how effectively our equipment is being utilized. So OEE is calculated by combining three key factors, which is performance, availability, and quality. So let's dive into each of these components. So first, availability. Availability measures the percentage of time a machine or process is operational as intended as its scheduled production time. So it is calculated using the formula total hours planned minus lost time over total hours planned times 100%. So essentially, this helps us identify and address downtime, so ensuring that our equipment is available when needed. So second is performance. Performance evaluates how consistently equipment operates at its maximum capacity. So it's measured by comparing the actual machine speed to its design machine speed using the formula actual machine speed over design machine speed times 100%. So this factor highlights inefficiencies such as running at suboptimal speed or minor stoppage. And last but not least is quality. So quality measures the percentage of product meeting quality standard out of the total produce. So the formula is number of good products over total products made times 100%. So this ensures we focus on minimizing defects and we work to maintain a high standard in output. So to summarize, OEE is calculated as availability times performance times quality. So by monitoring and improving these three aspects, we can enhance productivity, minimize waste, and also maximize the value derived from our manufacturing operations. Okay, so next we will explore the key reasons why organizations like Nissan adopt OEE as a cornerstone of their operational strategies. So at the heart of this discussion is OEE. That is a comprehensive measure that evaluates how effectively manufacturing operations utilize their resources. But why is it so widely embraced? So first, OEE reduces unplanned downtime. OEE helps to identify the inefficiencies, minimizing disruption caused by unexpected equipment failure. Next, measurable improvement in profitability. So by enhancing performance and productivity, OEE directly contributes to measurable gains in profitability. Next, improve quality and minimize reject. So tracking OEE ensures high quality output by reducing defects and improving product consistency. Next, improve on-time delivery. Efficient process lead to reliable delivery schedule, which meet customers' demand on time. Okay, so next, reduce setup and changeover times. OEE promotes lean practice, reduce delays during transition between production cycles. So next, better management of resource allocation, planning and scheduling. So with OEE metrics, resource allocation becomes more strategic, ensuring efficient production workflows. Next, efficiency with automated data collection. Automating data collection enhances accuracy and enables quicker decision making. Last but not least is the better root cause analysis. OEE provide data-driven insights, enabling teams to pinpoint and resolve issue effectively. So adopting OEE is not just about improving numbers. So it's about fostering a culture of continuous improvement. So it empowers team to make a data-informed decision, ensuring higher productivity and long-term success. Okay, move on to the next slide, which is 6 big losses. So these frameworks helps organization identify and address key inefficiencies that can hinder production process. First, the enhancement of manufacturing processes. So the 6 big losses is an effective method for enhancing manufacturing processes. By utilizing this approach, companies like Nissan can streamline their operations and achieve better productivity. Second, the primary causes of inefficiencies. So one of the vital aspects we focus on is addressing the primary causes of inefficiencies. So by identifying these root issues, we can implement target solutions that can lead to significant improvement. So third, reducing equipment-related issues. So this strategy is particularly aimed at reducing equipment-related issues within production workflows. So ensuring that machinery operates smoothly is crucial for maintaining consistent output and quality. Next, identifying root causes. So a critical element of 6 big losses is the emphasis on identifying and addressing the root causes of production loss. So by understanding what's truly behind these losses, we can formulate effective action plans to rectify them. Okay, fifth point is pinpointing fundamentally loss. So the framework also assists in pinpointing fundamental losses. So this enables us to minimize their impact more effectively, ensuring that we are not just treating symptoms but addressing the underlying problems. Okay, so next, reliable data for decision making. It allows for precise evaluation and provides reliable data for decision making. With a solid information at hand, managers can make informed choice that enhance overall productivity and efficiencies. So adopting the 6 big loss framework can lead to a transformative improvement in manufacturing. Okay, so next we will delve deeper into the 6 big losses, breaking them down into categories, their definition, and also their specific losses or causes associated with each. So first, availability. So this category addresses losses linked to downtime. Essentially, when equipment fails or breakdowns, it results in significant production losses. So common causes in this area include equipment failure and required setup and adjustment that halt operation. Second, performance. So this category deals with losses related to reduced speed on the production line. Situations like idling and minor stops contribute to this loss as they prevent the equipment from operating at its full potential. So it's essential to optimize performance to maintain productivity. So finally, we focus on quality. So this category addresses losses associated with goods that do not meet established quality standards. So issues such as process defects can lead to reduced yield, which further impact the overall efficiency and manufacturing. So ensuring quality control is vital to minimize waste and maintain high standards. Now let's take a closer look at the subcategories of availability, starting with equipment failure. Equipment failure refers to unplanned downtime when equipment is scheduled for production but unexpectedly stops due to unforeseen events. So this can significantly disrupt manufacturing efficiency. So some common causes of equipment failure include operator's error, inadequate equipment maintenance, software malfunction, and hardware failures. So to mitigate these issues, it's crucial to track downtime effectively. So this means recording the exact times when downtimes occur and documenting the reasons behind it. So by employing mitigation strategies such as predictive and preventive maintenance technologies, we can address potential issues before they arise. So the next subcategory is setup and adjustment, which involve planned downtime that occurs when equipment is intentionally stopped for scheduled events. So this downtime might occur for reasons such as product changeover, minor tooling adjustment, cleaning, routine maintenance, or quality inspection. So to optimize the impact of setup and adjustment, we should utilize planned downtime strategically. So implementing time adjustment allows us to make the necessary changes while minimizing disruptions. So by effectively scheduling these periods, organization can enhance equipment cleaning, calibration, and other maintenance tasks. So this in turn reduce the likelihood of extended periods of inactive and ultimately improve overall efficiency.
Thank you, Sabrina, for explaining the previous point. My name is Nirisa, and I will continue the next aspect of the 6 weeks losses, which focusing on the performance due to idling and minor stops, which might seem trivial at first, but they contribute significantly to operational inefficiencies. So, for example, is the production line where the machine stop for every few minutes because of the material misfit or jam. So this issue might only take a few seconds to address, but when we sum up the time, they might be affect the big loss of total lost time. So to tackle this issue, the first step is need to identifying the root cause of this stop. For example, is if the operators observe and document that conveyors jam are common things to happen, so they might discover that debris blow up is the underlying issues. So once identified, preventive actions like regular cleaning schedule can be implemented to minimize the downtime. So by addressing the idling and minor stops through consistent observation and proactive measures, we can ensure the smoother and more efficient operations. Now let's move to the next point of 6 weeks losses, which under the same umbrella of the performance, which is due to the reduced speed. So this occurs when the equipment operates below its optimal cycle time, leading to performance inefficiencies. So this reduced speed is often caused by the run out of the components or insufficient lubrications. For example, is a machine running slower because of its belts have worn out, will slow down the entire process, impacting the overall productivity. So to address this issue, we propose 3 approaches, which is first is document recurring slowdown to identify corrective actions. So for example, is if the machine consistently run down due to the old part, so scheduling timely maintenance can help. Second is automation can reduce manual errors and optimize cycle times. For instance, robotic arm can replace a repetitive manual tasks like assembly. So finally, is operator training is critical. So teaching operators how to handle the equipment efficiently ensures smoother production cycles. So by addressing this root cause, we can significantly improve the performance and efficiency. So our third big loss of the aspect under the quality, which focusing of the process defect that involve the producing the defective items that fail to meet the quality standard. So this defect often arise from incorrect equipment setting or operator mistakes. So for example, is a casting with crack due to improper cooling can result in costly rework or scrapping. Similarly, misaligned drill holes during fabrication can compromise the product quality. So we have three approaches here that focusing on monitoring inputs, leverage technology, enhancing um, training. So firstly is regularly inspect the inputs to maintain the consistency and quality. So for instance is testing the raw materials like steel for tensile strength before productions. Next is we use technology to catch the error early. Automated visual inspection system can check for misaligned labels on packaging. Last but not least is the provide hands-on training for operators. For example, these simulations can teach them to set the machines correctly to avoid the common errors. So by improving this input of monitoring, adopting technology, and investing in training, we can reduce the defects and maintain the high quality outputs. So the next point from the quality aspect is reduce yield, startup defects, defective parts often produced during the equipment startup. So the way or the solution to minimize the problem is to track the defect, which implement the data collection system to monitor defects separately for startup and production phases, as they may require different approaches to resolve. Next is preventive measures. Establish a preventive maintenance plan to address the potential issues proactively. Lastly is ensure the compliance. Need to train and ensure operators strictly follow the proper production procedures to reduce defects. So what is the strategies for zero breakdown? Firstly, we can train the operators to clean, to inspect, and to perform the basic maintenance on mission daily. Maybe here we need the supervisor to ensure that these operators conducting the cleaning, conducting the inspection, or perform the basic maintenance before they start the work. Second is develop a maintenance schedule based on equipment usage and historical data, because this is one of the way to minimize the 6 bit losses. Third is we can use sensors and data analytics to predict and address the potential failure before they occur. Fourth is we can continuously train operators or employees on maintenance best practice and involve them in problem solving activities, because in the training they have to hands on how to conduct the machine. Next is investigate and address the root cause of parts breakdowns to prevent the recurrence. Next is collaborate with the equipment manufacturer to design the machine that are easier to maintain and less prone to failures. Last but not least, we can also utilize the tools such as failure mode and effect analysis and condition monitoring system. So I pass the stage to Ahmad Farhan to explaining the case study of this presentation. Thank you.
Hello, Assalamualaikum. My name is Farhan. So I will continue on this presentation. In today's increasingly competitive industrial landscape, maximizing productivity and efficiency has become a cornerstone of operational success. One of the most widely adopted tools to measure and improve this aspect is overall equipment effectiveness, or we call as OEE. OEE as a multi-phase matrix that provide a holistic view of equipment performance by integrating three key dimensions, which are availability, performance, and quality. By analyzing these dimensions, OEE not only highlights inefficiency but also guides organization toward strategy improvement in their systematic production systems. So throughout this presentation, I will walk through the systematic approach to calculating OEE, showcase its practical application through a real-world case study, or we call it example, and demonstrate how it serves as a powerful benchmark for enhancing productivity. So the goal is not to only the present calculation, but also illustrate how OEE contributes to the long-term operational excellence and sustainability in industrial environments. So let's start for the example one. In this case study, we explore how YATEC Engineering address inefficiencies in one of its lathe machines. So the initial overall equipment effectiveness, or OEE, of this machine was recorded at 62%. So it is signaling substantial room for the improvement. To tackle this challenge, YATEC Engineering implemented Total Productive Maintenance, or TPMs, a strategic approach aimed at enhancing three critical components of OEE, which are availability, performance, and quality. So let's begin by examining the provided data. So planned production time is 480 minutes per day, downtime 9 minutes per day, actual output 80 units per day, ideal cycle time is 4 minutes per unit, and lastly defective units 5 units per day. So using this data, we can calculate the initial values of each OEE component. So the first step to calculate the OEE, we need to know the value of availability. So the availability for this is to measure the percentage of time the machine is operational during scheduled production period. So the formula is planned production time minus into downtime and divided into planned production time, and then we multiply into 100 in order to get percentage. So we substituting the values, 480 for the planned production time minus 90 for the downtime, and then multiple back into divided back into 480, and then we multiple into 100 in order to get the percentage, which is 81%. The next step 2 is performance. So the step 2 is to calculate the performance. This evaluates how efficiently the machines operates compared to its maximum potential. So the performance is calculated as actual output divided into ideal output and then multiple into 100 in order to get the percentage. So in order to calculate the performance, first we need to determine the ideal output first. So the ideal output is operating time divided into idle cycle time. So 390 is operating time divided into 4 idle cycle time resulted into 97.5 units. And then we calculate the performance. Operating time 80 divided into idle cycle time 97.5 multiple into 100 in order to get the percentage, resulted into 82%. And lastly, step 3, calculate the quality. So this quality is represent the percentage of product meeting quality standard. So the formula is quality, the total output minus defective units, and then divided into total output, multiple into 100 in order to get the percentage. So substituting the values, we result the 80 minus defective units 5 and divided into 80 multiple by 100 resulted into 94%. So after we get all these three data, we can calculate the OEE. So overall equipment effectiveness by combining these three components, availability times performance times quality, so resulted into 62% for this initial OEE. Following the identification of inefficiencies and a low overall equipment effectiveness of 62%, YTech Engineering adopted key pillars of total productive maintenance. These pillars were tailored to address the specific challenge faced by the late machines and improve its performance across availability, performance, and quality metrics. Let's explore the strategies implemented. So the first one is autonomous maintenance. So as you can see, operator were trained to perform regular inspections and basic troubleshooting tasks. So this approach allow for the early detection of potential issues, reducing unplanned downtime and improving equipment reliability. Next is a plant maintenance. So uniform maintenance checklists were developed and deployed. So these streamlined procedures ensure consistent upkeep of the equipment, preventing unexpected failures and minimizing production interruptions. And lastly, quality maintenance. So by implementing the quality maintenance, advanced defect tracking system were implemented to identify recurring quality issues. By analyzing these trends, processes were optimized to reduce defects and enhance overall output quality. So 5 months after post implementation of TPM, so the given the data resulted into the new, which is planned production time 480 minutes per day. New downtime is 60 minutes per day, reduction into 33%. And new actual output is 100 units per day. And lastly, new defective units 2 units per day, 60% of reduction. So by implementing of TPMs into the YTech engineering of the late machine, so as 5 months later, let's see how the effectiveness of TPM affected on the OEE based on the 5 months later data. So step 1 is we calculate the new availability. So the new availability resulted into 88%. And for the step 2, we need to calculate the new performance. And new performance resulted into 95%. And step 3, we calculate the new quality based on the data 5 months later. So the new quality resulted into 98%. So on the OEE, so we calculate the OEE resulted into 82%. Through the implementation of the TPMs, the plant achieved a reduced downtime by 33%, and availability improved from 82 to 88%, and performance increased from 82 to 95%, quality enhanced from 94% to 98%, and OEE increased from 62% to 82%. In conclusion, OEE is a tool can identifying inefficiencies in manufacturing. By focusing on availability, performance, and quality, businesses can pinpoint weaknesses, implement targeted improvements, and achieve significant gains in productivity. So the example demonstrate that total productive maintenance is proven for boosting OEE, leading to better operational outcomes and enhance the profitability.
So what can we conclude for the overall presentation, saying that the implementation of TPM and OEE has proven to be a transformative approach in optimizing operational performance across industries. So by addressing the key pillars such as autonomous maintenance, plant maintenance, and quality maintenance, organizations like Nissan and the study cases at YTech Engineering demonstrate that significant enhancements in equipment availability, performance, and quality. At a broader level, the finding affirm that proactive and preventive maintenance practices are essential in modern manufacturing and energy sectors. The integration of advanced technologies such as predictive maintenance tools and defect tracking system complement traditional TPM methodologies, ensuring sustainability and adaptability in dynamic operational environments. Moving forward, TPM's role as a cornerstone of lean manufacturing strategies will remain pivotal in driving efficiency and achieving excellence in equipment management. Thank you for our group.